Hello and welcome to 11th lecture in third chapter of our comprehensive course on machine learning, data science and artificial intelligence. In our previous lectures, we were discussing these four concepts, which are the four important pillars of object-oriented paradigm: encapsulation, inheritance, polymorphism and abstraction. So far we have discussed the first two. So now it is time to discuss the third, polymorphism. This is slightly longer lecture, so please pay attention, but it is worthwhile to learn this. First, I read the definition of polymorphism. Initially, you may find that things are not very clear, but when we take the example, then things would be clear. Polymorphism gives a way to use a class exactly like its parent so that there is no confusion with mixing types. Now, what is the meaning of this sentence? Let us say this example, which is given in the diagram. Suppose you want to define a class which creates a circle object and find this area, then which creates the square object and find its area, and which creates the triangle object and find its area. But is it necessary to implement find area function or method independently in all, or one can do one thing? Ultimately, circle is also a shape, square is also a shape, and triangle is also a shape. So we can define this basic class or superclass called shape, and we can define one method, find area. But we do not write any implementation, any code how to find area. We just leave by giving pass. That means it is some kind of abstract method, just a placeholder. How to find area, that implementation we will do differently, because the way of finding area for circle is pi r square. R is the radius. For square it is length square, and for triangle it is half base into altitude. So there will be different formulae for finding area for each shape. So here we will not implement, but we are using the same name that you can see. Red color is the find area method in the superclass, and all black color are the find area methods in each of the subclasses. But name remains the same. Now if you read, then this sentence will become clear. It is a way to use a class exactly like its parent class. So the circle class is exactly used like its parent class. We can use the find area method, but doing something so that there is no confusion with mixing types. You have to do something so that otherwise this find area, how will we distinguish find area method for type circle with find area method of type square with find area method of type triangle? We cannot do that unless we implement this find area in a different manner, pi r square, this length square, and this half base into altitude. So names are kept same, but we implement them in a different manner so that the types, that is the circle, square and triangle, they do not mix with each other. That means this find area method is having same name, but it is having different forms. That exactly is called polymorphism. Actually, the word itself is very clear. Poly means actually means many, and morph actually means forms. So polymorph is something which has many forms. For example, this method find area is called a polymorphed method. Okay, that find area method in the base class and find area method in circle class, square class, and triangle class, they will have same names, but they have different implementation and different behavior. Their format is different. Let us make it clear. Here we have to import this math library of Python, and first let us implement the base class, that is class shape. As I said, that has the method find area self, but we will not give any implementation. We will just write pass. I have very clearly said that it is just a placeholder. Where the implementation will come, that will come in the child object or child class. Now there is first child class for this circle. So now class circle, and in bracket shape means class circle inherits from this superclass shape. So it will also have find area method, but we are now defining that find area method by a different way. So this is called overriding of that method. That find area method is overridden. Then always the subclass implementation takes precedence over the superclass implementation. As such, in superclass there is no implementation at all. We have just given pass. But in subclass there is an implementation like this. Okay. So, and of course this constructor is required because superclass does not have any constructor. So you have to provide a constructor in this class. Okay. So this constructor takes one argument, radius. Self is always there, and then self dot radius is equal to radius. So now I create a circle object using this circle class. So circle is equal to class circle. Object is written with small c. Class is written with uppercase C. So I'm calling my child class circle, and I'm supplying with radius 5. Where will this value go? This value will go here. So that means that an object of circle class will be initiated with radius equals 5. And then this find area will be pi multiplied by 5 multiplied by 5. So 5 multiplied by 5 is 25, and then this is pi, which is around 3.14. For simplicity, I can take radius equals 10, so that it should be roughly around 340, and I'm printing the area. Okay, so let us see. First I have to define the class, and then I am printing the area. You can see that the area is 314 because pi is 3.14 roughly, and this is the 10 square. Radius is 10, so 10 square, so 340. Now I can do another square class also, which also is a child class of the shape class. Okay, and there you can again provide a constructor with one parameter length, and now you call it. So square equals square length equals 4. So that length equals 4 will go here 4, and it will be assigned to this. So length of this square object which is instantiated, this object, its length is 4. And then for square the area is found by length multiplied by length. So this is the find area method which is implemented for the square class. So let us say it should be 4 multiplied by 4, 16. Again, sorry, square class must be implemented first, and this is 16. Fine. Now this is triangle class, third class. So triangle class is also derived from the super class shape. So it is inherited from the superclass shape, and this is the constructor of triangle class. Let us try to create a triangle object. So triangle object is equal to calling the triangle class with base is equal to 6 and height is equal to 3. And the formula is half base into altitude for the find area. So half into 6, that is 3, multiplied by altitude, height, that is also 3. So 3 into 3, answer should be 9. And we can print that area. But first, this time I don't want to make mistake. So yes, so area is 9. Half base is 6, so half of 6 is 3 multiplied by height is also 3, so 3 into 3, that is 9. So this whole is the example of polymorphism, and of course with that this is an example of inheritance also, that classes, these three specific shapes, circle, square, triangle, they are deriving themselves from parent class shape. Okay, fine. Now this is one built-in function in Python, len, and it also behaves in a different manner depending upon on which object it is called. Okay, let me a little bit magnify this just for clarity. Okay, so if I call len for string object, then it will give the number of characters in string. If I call len with a tuple object, then it gives the number of members in that tuple, or list also, it can be list also. And if I call len on a dictionary object, then it gives the number of key value pairs, how many key value pairs are there in that dictionary. I have given 4 examples also. Okay, so this, let us say len is a built-in function, so I don't need to implement like here we implemented this find area. Here len is a built-in function in Python, but let us apply len to string, let us apply len to list, and let us apply len to dictionary. So len will behave in a different manner. First, this is for string, this is for list, and this is dictionary. And you can see that here it counts number of characters, here it counts the number of members in the list, and here it counts the number of key value pairs in the list. So this is another example of polymorphism. There is a single function len in Python, but it takes different forms. Poly, many, forms means morphs. So len function, built-in function, exhibits polymorphism. Okay, fine. Now let us revisit our definition of polymorphism, and now things will become clear. Polymorphism gives a way to use a class exactly like its parent that we have seen in that shape and circle, that all have method find area, but in some that way that there is no confusion with mixing types. Circle type should not mix with square type, should not mix with triangle type, and for that we do implementation of that find area method in the parent class as just abstract, a placeholder, but in each child class, circle or triangle or a square, we provide different implementation. This differentiation between various different morphs or forms, that is achieved by overriding methods in subclass or by methods such as those in different classes that share the same name. So overriding the method means find area method we have provided in the superclass, but we did not implement it in the shape class. We just provided pass, but we are overriding that method in each of the child class, and we are providing different implementation with depending upon shape. Okay, here it is a different implementation depending upon shape. Here it is a different implementation depending upon shape. So this is how this can be found. Now this sentence says that there are actually many ways in which polymorphism can be implemented. There are 4 ways. One is by duck typing, by method overloading, by operator overloading, and by method overriding. Initially, I had decided that I will not go into this discussion, and therefore I had written that detailed discussion of these is in the scope of advanced course, because uh, this I intended to first make this course in multiple parts: basic data science, intermediate data science, and advanced data science. But after putting some efforts, I realized that it is better to give everything to in one only, but mention that this is an advanced topic. So those who don't want to go into that, they will not go into that. So in a way, those who are attending this first lecture, first course, they are lucky, because I originally intended I will design multiple courses and sell them one by one. But you are getting everything in one course only, and probably there won't be another course. So I want this course to be all inclusive. So you are lucky in that sense. And even those who are beginning, they can initially avoid this mm, topic, and they can proceed with the next topic. There will not be any breakage in the continuity. I can ensure that. You just look that these are the four ways of implementing polymorphism in Python, but then directly the discussion of those four ways here is given. You can skip that discussion and you can directly go to this abstraction, fourth pillar of object-oriented paradigm. But after spending maybe 1 year, 2 years in actual field, you will feel that okay, now I want to learn this polymorphism in more detail, more depth. Maybe you have encountered some assignment at your job, or you are doing some further studies. Then at that time, you don't need to buy another course. This is the first and the last course. Okay, and any additions will be done only in this course. Thank you. We will continue with this discussion of these four methods in next lecture.